Now, we have done this math or not? We have done it. Everyone, we have done it or not?
No, sir.
No, not yet. Okay. So we will do the math today. Okay. First, we'll start with this one. They said this is the circuit basically. This one is the circuit. They said determine the ID, VD, VD2 actually. VD2 means this voltage. That means this silicon's voltage is the VD2, and VO. VO is the voltage of this point. This point means, remember, the voltages are of two types. Okay, one is voltage difference, another one is point voltage. So one is voltage difference. Okay, let me write. One is voltage difference. Another one is point voltage. Okay, what is the first one? Which one is voltage difference? Voltage difference means you have to find the voltage between 2 points. When your what is that? When your voltage has a plus and minus sign, you have to understand this is the voltage difference. First one. In most cases, you find the voltage difference. Okay. Although I said find the voltage, or calculate the voltage, remember in 99% cases you have to find the voltage difference. Okay. Voltage difference means your plus and your minus is given. That means you have to find the voltages of this point and this point, then you have to subtract them, then you have to find out the voltage difference. That means this one. So you have to find this voltage and this voltage, then you have to subtract, then you have to find out this one. This is the voltage difference. Understand? Now the point voltage, okay, by the way, what is this actually? This 5.6, the plus minus is given. That means that this is the point of where you are saying it is plus. This is the minus point where you are indicating this is a minus. So find that, make a minus. That means plus voltage minus voltage. Because you have a plus, so it will be plus. You have a minus, so it will be minus. So we can say we have to subtract. We have to subtract this voltage from this voltage. That will give us the VO. Remember, okay? So we have to find both of them. Then you have to subtract these minus these. Then you can find out the VO. This is voltage difference. And what is point voltage? Point voltage means when you do not have any second point. Here the points are given. Plus point, minus point is given, right? So you can find and you can make a minus, no problem. But when there is no second point, that time that will be called point voltage, like this one, VO. In the question, they didn't say the second point. They only say one point, that is VO. So how to find out? Okay, how do we find out the what is that? The actual voltages. How we find the voltages? We find the voltages using multimeter, right? You all know we find the voltage using multimeter. Okay, let's bring a multimeter. Let's say this is our multimeter and it has 2 pins actually. One is red pin, another one is black pin. We all know it. Multimeter, you have seen it in the lab, right? You have seen it, multimeter. Now, where we have to find out, okay, in case of VD2, that means the 2 point, that means the voltage difference. What we do? We actually take the plus, we actually take the plus, it means the red one, and put it here. And then we take our black pin or the black wire and put it here. So what happened? They actually subtract. This multimeter actually subtract the voltage from these and to these. That means these minus these. They subtract and give us a result. Understood? This is called voltage difference, finding out the voltage difference. But what we will do in case of this one? In case of this one, what we will do? In case of VO, what we will do? We will put the red pin, because the point is given, point voltage, no plus minus given. So we will put the plus red pin into the point. Where we will put our black pin? Anyone, give me an answer. Where we will put the black pin? Where? Anyone, please give me an answer. Where we will put our black pin now?
Sir.
Yeah. Yeah. One of you said. One of you said the answer.
Near the ground.
Near the ground. Exactly, ground. So we need to put the we need to put the black pin near to the ground, right? Near to the ground means this one. So when the second point is not given, we have to put the second point, that means the black pin near to the ground or to the ground, right? Now here, you have to understand what we are measuring now. We put the black pin to the ground. So what we are measuring? We are actually measuring the voltage of the resistor, right? Because you have only one thing in between that plus pin and the minus pin, that is the resistor. So we are actually measuring the voltage of the resistor. Okay, so we can find out that. Now the basic is clear. Yeah, the basic is clear. We are going to okay, wait here. Now the basic is clear. Now we will start solving these. Okay. At first, what we have to do? Remember, we need to redraw the circuit first. Redraw. We will redraw the circuit. Okay. We will redraw the circuit by using what? Using the black pin. Why? Because we have a plus 20 volts, so we will convert that into a battery. Because plus 20 means we have a battery. The plus pin is connected. Where is the minus pin? Where the minus pin will go? To the ground, right? Plus pin is connected. That's why it is plus 20. And where is the minus pin? Minus pin will go to the ground. Ground means from here or here, same thing. So we can connect them together. So plus is connected to the circuit, minus is connected to the ground. So okay, let's give plus and minus, and the value is 20. Okay. Now, since the current is going in this direction, right? Why the current is going in this direction? Because the current direction is given. ID, IR is given. Direction is given, right? The current is going in that direction. So what will happen? We will have a plus minus. Here, this will be plus, this will be minus, because we all know in case of components, not the battery, other components like a diode, resistor, and everything else. In case of component, the direction of current will determine the plus and minus. In in which way the current is going, that will be your plus. Since the current is going in this direction, so first point will be your plus. The current is leaving from here, so this will be your minus. Understood? Plus and minus. So this is your plus, this is your minus. Again, the plus minus is also given. Plus, this one is plus, this one is minus for this diode. For this resistor, this will be plus, this will be minus, because current is going in this direction and leaving from here. So this is the entering point of current, this is the leaving point of the current, that's why it is minus. Now we will apply a KVL. How to apply KVL? Remember, KVL has two ways. One is the first sign ways, another one is second sign way. Okay? First sign means you have to choose the first sign, and every time you have to do the KVL. Remember, in clockwise method, clockwise. So we will apply the clockwise method, and since we are using the first sign or the second sign, so every time we have to do that. If we choose the first sign, you have to choose these. This is the first sign, this is the first sign, this is the first sign, and this is the first sign. But personally, I do not like the first sign method. I like the second sign method. Second sign method means this one, this one, this one, this one, this one. Okay, you can use the first sign as well. So let's start. Second sign, that means the green one, this green, 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 right? So here, plus. So plus 20, then minus. What is the voltage of this silicon? In case of forward bias, it was supposed to be 0.7. That means if current flows, this silicon voltage will be 0.7. We know it. But there is a but. What is that? In this circuit, you do not have any current. Why not? Can anyone explain why there is no current in this circuit? Why there is no current in this circuit? Anyone? Can anyone explain why there is no circuit in this circuit? There is no current in the circuit? No one? Okay. There is no current in this circuit because one of our silicon is reverse bias. This silicon is reverse bias. That's why no current will enter. Not even these, not even that. So since there is no current in the whole circuit, so this silicon will not take any voltage. Remember, this silicon will not take any voltage. So the voltage will be 0. What about this voltage, VD2? We do not know yet, because that is reverse bias. Reverse bias, we do not know. So let's write minus VD2, because we are choosing the second sign, minus VD2. And what about the voltage of the resistor? Voltage of the resistor. The voltage of the resistor, okay. What about the voltage of the resistor? Voltage of the resistor, we do not know yet now. But remember, since our current is 0, this current is 0, right? This current is 0. Because there is no current because of the silicon, one of our silicon is reverse bias. So no current. So what is the voltage of the resistor? According to the Ohm's law, V is equal to IR. I into R. Since your I is equal to 0, your ID or your IR is equal to 0, right? Because you have one silicon that is reverse bias. Since these are all 0, so your voltage of the resistor, V is equal to IR into R, will be 0 into 5.6 equal to 0. That means this voltage will be 0 volt. So I can write I can write 20 minus 0 minus VD2 minus 0 is equal to 0. What 0 is this one? This 0 is the ground 0. That's why. So this is the KVL. So 20 minus 0 minus VD2 minus 0 is equal to 0. So from there, which is unknown? VD2 is unknown. Let's take that VD2 because all 0, they are actually cancelling each other. Zeros has no value. So they will be gone. So this VD2, take the minus VD2 and put it at the right side of the equal sign. So that will be plus. So take that VD2 to the opposite side of the equal sign. So there will be, this will be plus. Oh. So I can rewrite it. $20 equal to VD2. How? Let's take this minus VD2 in the opposite side of equal. So they will go, so VD2 is equal to 20 volt. Understood? This VD2 will be 20 volt. What about the VO? What about the VO? For VO, you have to take one multimeter. Remember, let's take a multimeter. Again, you have a red pin. Since you have to find out the voltage of this point, take the red pin and place it here. You need a black pin. Take the black pin, put it in the ground. So what actually you are measuring? You are actually measuring the voltage of, you are actually measuring the voltage of the resistor, right? What is the voltage of the resistor you find before? Anyone? The voltage of the resistor was V is equal to IR. That means IR into R. That means actually 0 volt. And this voltage will be called VO. So VO is equal to IR into R, that is 0 volt. Understood, everyone?
Yes, sir.
Okay.
Yes, sir.
Okay, thank you. Now we will move to the next math. Okay, here they explained in a different way. What is VD2? VD2 is an open circuit. Why open circuit? Because this silicon is reverse bias, right? Reverse bias means there is no current. No current means that is open circuit. If you have an open circuit, like this, all of your voltage will go and accumulate it there. Since your voltage will not drop anywhere, silicon will not take any drop, your resistor will not take any drop. So all the drop will be at the open circuit. Okay, so your VD1 is equal to 0 volt, your VO is equal to 0 volt, so your VD2 will be 20 volt. So that is one method. But I apply KVL, I show you how to use KVL. Understood? Now, let's get back to the next math. Next math. Okay. First one is determine, okay, this one. They said determine I means this current, V1, V2, and VO. This was V1, this is V2, and you have to find out VO. Remember here, first V1 is a voltage difference. That means plus minus is given. V2 is voltage difference because the plus minus is given. But VO is a point voltage, right? So you have to find all of them. Now, how to do that? At first, complete the circuit. How to complete the circuit? Before doing anything, let's redraw the circuit using batteries. Here it is plus 10. Plus 10 means you must have a battery and the plus is connected to the circuit. What about the minus? Minus is connected to the ground. Pretty simple, right? Whatever, here you have another battery that is minus 5, right? Minus 5 means that is actually a difficult one. Minus 5. Okay, let's redraw the circuit by using another battery. What battery? We will give a 5 volt and the minus will be connected because it was minus 5, and the plus point will be going to the ground. Understood? Plus 10 means plus is connected, minus is ground. Minus 5 means minus is connected, plus is going to the ground. Who didn't understand this? Anyone? Anyone? I believe you understand all of this, right? Plus 10 means plus will be connected, minus is ground. Minus 5 means minus is connected, plus is ground, right? So here we have two grounds. We can actually make them together, no problem. We can actually combine them together because all of them are ground. Now we can apply a KVL. And since the current direction is given, see current direction? The current direction is given, right? This is the current direction. So we can write some plus and minus. So this is your plus, this is your minus, this is your plus, this is minus. For silicon, this will be plus, this will be minus. Why? Because current is going in this direction and it is forward bias, so this is plus. For resistor, the plus minus is also already given. So all of them are already given, right? Now we apply a KVL. How to apply KVL? See, we will use the second sign. That means this is the second sign. This is the first sign. This is the second sign. This is the second sign. We will apply the minus. This is the second sign. That is the minus. This is the second sign. That is the minus. This is the second sign. That is the plus. So we'll apply all the second sign. How to do that? See. So at first, plus 10 minus. Next one is V1, right? Minus V1. Next one is 0.7 because there is silicon. Silicon take 0.7 if it is forward bias. It is forward bias. Yeah, 0.7 exactly. Very good. Then minus V2. We do not know the V2 yet. We will find out. Then plus 5. Equal to 0. Now from here, plus 10 plus 5, that is 15. We know it. So let's write 15. And minus 0.7, that is 14.3. So let's write 14.3. Now you have minus V1, minus V2. Take them on the opposite side. Plus V1, plus V2. Now I'm going to give you 2 minutes of time and start, I will ask you to solve this. Do not see the book. From here, find something and come back. Okay, I'm going to give a pause of 2 minutes. Only 2 minutes, no problem. Only 2 minutes. Find something from here. Oh shit. I should not be. What is that? I should not be removing it. So 14.3 equal to V1 plus V2. That was the answer. I will try. I will tell you to find something from here. Okay. Okay. Did you find out anything? One of our things just gone, so we will try to figure it out again, and we will try to draw the circuit again. This was plus 10, this was minus 5. So we will draw the circuit. This is plus 10 to the ground, and this is minus 5 to the ground. Okay. Now here, see this. Here plus V1 and V2. V1 is the voltage of the resistor. V2 is the voltage of another resistor, right? So the voltage of the resistor has a formula, I into R. We know it. What is the I? I is this one. So we can write I into R1. What about the V2? V2 is I into R2. I into R1, I into R2. That is the formula, V1 and V2. We all know it, right? Because of the Ohm's law. So from there, we can take I common. If we take I common, your answer will be this one. So 14.3 is equal to I into R1 plus R2. We all know it, right? Very simple. Here, which one is unknown? R1 is known. R1 is 4.7. R2 is 2.2. That is, those are known. Which one is unknown? The unknown thing is the I. The I is unknown. So we can find out these by take this, the R1 plus R2 at the bottom of 14.2, 14.3 by dividing. Take that at the bottom by dividing. Okay. Now I'm going to do that. So 14.3 divided by R1 plus R2. R1 is actually 4.7 plus R2. R2 is 2.2 equal to your I. Remember, both of them are kilo ohm. This is kilo ohm, this is kilo ohm. This is volt, this is volt, this is kilo ohm. Volt divided by kilo ohm will be milliampere. Your answer will be milliampere. Let's find out. Using calculator. Fourteen 0.3 divided by 4.7 plus 2.2 kilo, remember. So the answer will be 2.07. 2.07, right? 2.07. Let's write it. So answer is 2.07 milli. That is the answer. Remember, 2.07, that is the answer, 2.07 milliampere. So we got the value of I already, right? So let's erase everything from there. 2.07 . Now we will find out the voltage of V1, V2, and VO. V1 is a point voltage. That means the voltage of the resistor. Can you see that? It is the voltage of the resistor. Now, voltage of the resistor, the voltage of the resistor will be I into R. We already know the value of I. We know the value of R. So find the voltage of V1. So your V1 equal to I into R1. So let's give some space. Okay, equal to, what is your I? 2.07. 2.07, remember, milliampere into, units are important. Okay, by the way, can you see this, or I need to make it bigger? How to make it bigger? Is there any way? No, no way. 2.07, then we have to multiply the value of the resistor, 4.7. 4.7 kilo ohm. Now the ohm, I do not have the ohm sign here, so I will write OHM. In your calculation, you write ohm, or if you use Word, Microsoft Word, you can write ohm. But here I cannot write ohm. Okay. Now the calculation will give us a value of, let's see what value it gives. 2.07 into 4.7. That gives us 9.729 or 9.73. 9.73. So equal to 9.73 or 729 volt. That is our answer for V1. For V2, V2 is the voltage of this resistor. This resistor. Now the voltage of the resistor is equal to I into R. We already know it. Let's find out. V2 equal to I into R2 equal to 2.07 milliampere into 2.2 kilo OHM, kilo ohm. If we do the multiplication, what will be the answer?
4.554. 554.
4.554 volt, right? That is the answer. So V1 and V2, the answer is given already, right? We already know it. 4.554. Now, these are all easy. Now the second part, that means the VO, that is the most challenging part of this of this problem. So for that, we need to use a multimeter. Remember, this is our multimeter. Let's say it has a plus and minus point. So if it has a plus and minus point, where we will put our plus point? Where we will put our plus point? We will put our plus point at the point where the voltage is there. What that point? This
Yes.
is the point, right?
Yes.
Okay. We need to put our plus pin there. What about the minus pin, that the black pin? Where we will put it?
Near the ground.
At the ground. This is the ground, right?
Yes.
So in between these 2 points, what you have? You have a resistor and you have a battery. You have V2 and you have a battery, right?
Yes.
But see, your battery is opposite. So your V2, by the way, your V2 will be plus. Why? Because the plus is near to plus, right? So V2
Yes.
will be plus. This will be our sign, and we will take this sign. Why? Why we will take plus for this one? Why we will take minus for this one? Because we will take the sign near to the plus. That means there is a red wire, near to the red wire. The sign for this one near to the red wire is the plus. For sign for this one near to the red one is minus. So we will take plus V2 minus 5. So our answer will be VO equal to plus V2 minus 5.
5.
Understood? So plus V2 means what?
Yes.
So plus
4.5
4.554 volt
minus 5.
minus 5 volt, right? Maybe something minus
This is 4.5
0.457,
or
something like
4.5.
4.5, right? 0.45,
Yes.
something like that.
Yes.
Something like that. Understood? You understood the problem?
Yes. Yes, sir.
Okay.
Yes, sir.
Are these very easy for you?
Yes.
So we will go to the bigger problems. We'll go to the bigger problems. Yeah.
Yes.
Okay. We'll go to the bigger problem. This one is a bit. I'm not say complicated. This one is easy as well, but you have to understand this. Let's draw and hide this. Oh no, I made a mistake. Let's draw and hide this, okay? So that we can write something here. Here they say determine VO. VO means the voltage between this point and this point. So plus minus is given. Determine VO. I1. I1 means this. What is that?
I want the
This
current.
current. ID1. ID1 is this current. That means this silicon diode. ID2 is this current. And okay, for the parallel light configuration, remember they are parallel and both of them are forward bias. How do I know both of them are forward bias? Because this I1 will come and will go to the downward position, right? This
Yes.
I1 will try to go to the ground. So they are in forward bias. This silicon, both of them are forward bias. And since both of them are silicon, both of them will take 0.7, 0.7 because in parallel voltage remains same. In parallel voltage remains same. So if this is 0.7, this will be 0.7. And since both of them are taking 0.7, so they will be on. Both of them will be on. Okay? I will explain with the problem with one silicon, one germanium. I'll explain that. Now, at first, here, what we have to find out? We have to redraw the circuit first.
Yes.
This is our voltage 10 volt. Plus, minus. Then we have a resistor. Then we have silicon. Okay, let's say this is plus 7. Because I know the silicon will take fixed plus 7. That means, not this. Fixed 0.7 plus 0.7. We know it. That's why we will draw like this. We will represent that with a voltage source, fixed voltage source. And that is our ground. Okay? Now this is our redraw circuit. So now we have to find out the I1. So where is I1? I1 is actually going in this direction, right?
Yes.
Okay. Now apply a KVL. Since current is going in this direction, so this will be your plus, this will be your minus. Now we can apply a KVL. How to apply KVL? So we'll take the what sign? We'll take the second sign. So this is our plus, this is our minus, this is our minus. So we will take this sort of sign, plus, minus, minus. Now apply here, plus 10, minus what? This voltage, right? What is the resistor voltage? I into R. What is I? I is equal to I1 into R. Then minus 0.7 is equal to 0. You understood?
Yes, sir.
Okay. Now the next one. So from here we can find out the value of I1 because R is known. R is 0.33. That is known. So from there we can say
Sir,
Yeah,
I want to ask you one question.
of course.
We have two silicon diode.
Yeah.
So, and then we take 10.7. Why?
Okay. That is a very, very, very good question. I will explain in a second. Okay. In a second. Wait. Very good question. I am very happy that you asked. Okay. 9.3. From here, we will find the value of I1 first. I will explain later in a moment. Wait. R1. R1 is 0.33 kilo ohm. Okay. From there, we can find the value of doing the calculator. 9.3 divided by 0.33. It will be in milliampere. Remember, 28.18 milliampere. 28.18 milliampere. So 28.18 milliampere. Oh no. Milliampere. That is the current of I1. Since we have a I1 here, remember, this I1 will come and will be divided into two parts. One part will go there, another part will go there. Understood? Pretty simple,
Yes,
right?
sir.
This one, 28.18 will come here and divide. Now, if you had resistors, two resistors, this would divide by using current divider rule. Very simple, right? Current divider rule. You have learned about current divider rule in your circuit one?
Yes, sir.
Okay. They will be divided according to the current divider rule, but we do not have any resistor here. We have two identical diode, two silicon, same diode, right?
Yes,
Since they are same diode, so the current will be divided equally. Current will be divided
equal.
equally. So 28.18 will be divided equally and will become ID1 and ID2. So your ID1 equal to ID2 equal to 28.18 divided by 2. So how much? Maybe 14.09.
Yes.
Both of them are equal current. Okay, you understood? You understood this? I
Yes,
believe.
sir.
Now come to your question. Okay, I'm going to
Okay.
come to your question. Now see here, I'm going to draw another +7 because you told me, sir, we have two silicon diodes. So why we have done only 1.7, right?
Yes.
Okay, now I'm going to draw 2.7. This is your plus, this is your minus, 0.7. I already given the answer, but maybe for some reason you didn't understand what I have said that time. See, for one silicon diode it is plus 0.7. For another silicon diode it is another plus 0.7. But in parallel, voltage sources remain same. So if you add two batteries, see, if you add two batteries in the same direction in parallel, they will have the same voltage. So if you use 5 volt together in parallel, they will give you 5 volt. Okay, because in parallel the voltage remains same. Since they are parallel and they are in they have the same value, 0.7 and 0.7, what will happen? They will give you only 0.7. That means only 1 volt, not 2. They will give you combined 0.7. Got my point? See here, if you have +5, if you have another +5, both of them are parallel. 5 volt, 5 volt, both of them are parallel. So how much volt this resistor will get? How much volt?
5 volt.
5 volt. Why? Because they are parallel. These two are parallel, so it will give 5 volt. But the current will be double. The voltage may not increase because of the parallel connection. The voltage may not increase, will not increase because they are parallel. But what will happen? The current will be double. Remember,
Yeah.
in parallel, if you connect two batteries or two sources in parallel, voltage will not increase. The current will increase. Understood?
Yes, sir.
In series, if you connect the battery, the current will not increase, the voltage will increase. In case of this one, current will increase, not the voltage. But if you connect them like this, the current will remain same, but the voltage will increase. So there are two methods of connecting batteries. If you connect them in parallel, the voltage will be same, but the current will be double. In case of series, the current will remain same, the voltage will be double. Okay?
Yes, sir. I understand.
You understand? So since we connected the silicon diode in parallel, so the voltage remains same. That means 0.7. So now, if you want to measure the voltage of these 2 points, that means the plus and minus VO, right? This is the VO.
Yes.
So you need a multimeter. Take the multimeter. Take the plus pin. Where? Here. And take the minus pin.
To the minus, yeah.
The minus. So what you are actually measuring? You are actually measuring these 0.7, right?
Yes.
Because they are parallel. So your output will be 0.7. Your VO will be 0.7. Understood?
Yes.
Pretty simple. Okay?
Yes, yes.
Okay.
Because before 1 minute ago, you said to us when the batteries is connected in parallel,
Yeah,
the
they will
voltage
be same.
is same.
Yeah. Now,
Yes.
now I'm going to give you one more example. Okay, I'm in the same example. Just I'm going to give a modification here. Modification. See everyone. One modification. Same math. Same math. Just germanium. Do you know what is germanium? Germanium is a diode. That
Yes.
is, you already know it, right? Germanium.
Yes. 0.3.
Yeah. Now find the math. Do the math. Everyone. 0.3. Remember. Do the math. Everyone. This might come in your exam. Might. Do the math. I'm going to give a pause for 2 minutes or 3 minutes. Do the math. Find VO, I1, ID1, ID2. All of it. Okay?
Yes, sir.
Okay, done.
Yes, sir. I tried.
You tried. Okay, what is the answer?
The answer for the first I is
For
29.
I one, sir.
No. At first, tell me the value of VO. VO first. How much is VO?
VO 0.3.
0.0 what?
0.3 for
Why not 0.7?
germanium.
Why not
Uh,
0?
because VO and germanium is in
Okay,
parallel.
okay. 1 minute. Huh? Okay, 1 minute, please. 1 minute. Now what?
View.
Now 0.7.
Now 0.7.
Yes.
Okay, I gave you the trap and you fall you fail on it. Okay, now here, this is one very important math. That's why I have swapped the VO and the silicon and the germanium. See, if the germanium is on, that means the current is going in this direction, right? This is a very important math. See, if germanium goes through, if current goes through these, that means if there is a current, no. If there is a current, right? That means the germanium will take 0.3, of course, right? Okay, let's redraw the circuit again. This is 10 volt. Then you have a resistor. Then you have 0.3, right? This is 10. This is 0.3. That means your germanium is taking some current, right? Now, if current goes through these, it will have 0.7, right? For sure.
Yes.
For sure. It will have 0.7 if current goes through these. So 0.7. Now, if you take a multimeter, and place the red pin here and place the black pin here, what will happen? What will be your reading? Which one it will get? 0.3 or 0.7?
0.7.
No.
Okay.
No. One important thing you have to understand: you cannot have two different voltages in parallel. No, you cannot. You cannot have two
So
different voltages.
you
Okay, sir.
you need to solve the parallel voltages.
Yeah, exactly. I told you before, the parallel voltages will be same. The parallel voltage will remain same
Yes.
if the voltages are parallel. Since they are parallel, so they should remain same, either 0.3 or 0.7, either one.
Yes.
Which one? Now, let me give you an example, right? Let me give you an example, one practical example, I must say. Let's say you have 100 people here, 100 people, they are going. This is, let's say this is, no, let's say this is Bonani. This is Bonani, right? Let's say this is Bonani. This place is Bonani. And this place is Boshundara city. Understood? Bonani and Boshundara city, you have 100 students. Now, I told them, go to Boshundara city, right? Now, you are moving. Now, at this point, you have two paths, two ways. That means, you have two paths, two roads, okay? If you follow this road,
Okay.
you need 1 hour. 1 hour to reach, right? And let's say 100 taka. If you follow this road, you need 1 hour and 100 taka. But if you follow this road, you need 2 hours. Which one you will choose?
And 1 hour.
1 hour, 1 hour.
How many of you will choose the 1 hour road? This one. How many of you?
Most of them.
Most of them. That means I say 100 of them will choose the this road, right? Because this is easier
Yes.
to go. This one is tougher to go, so no one will choose that, right? Remember. Okay, understood?
Yeah.
Okay. Now let's come to another discussion. If for some reason I said this one will take 1 hour and 100 taka, this one also take 1 hour and 100 taka. Both of them are same. Now, how many of you will choose this road? And how many of you will choose this road? If I say both of them will take equal amount of money and equal amount of time, how many of you will choose the first road? How many of you will choose the second road? How many?
Most of them will choose fast road.
Why?
Because fast road is easier.
No. I said both of them are easier. Both of them will take same money. In second case, both of them are taking 100 taka and 1 hour. This one 100 taka 1 hour, 100 taka 1 hour. Both of them are same. Now, if they are same, how many of you will choose the first one? How many of you will choose the second one? It's 50-50. Some of you will
Yes.
choose the first one. Some of you will choose the second one. If both of them are equal, right?
Yes.
Understood? Okay.
Yes.
So that's why both of them are having current. Having current means having students, right? But
Yes.
in first case, when I say this one is taking 100 taka and 1 hour, this one is taking 200 taka and 2 hour, nobody will choose it. Nobody will choose it. Everybody will go through that, right? Everybody will choose the germanium. If everybody choose the germanium, so there is no current in the silicon. If there is no current in the silicon, no 0.7 volt will not be there. Only 0.3 will be there. Understood?
Yes, sir.
Again, if no students are going in this way, that means no current is going in this way. No current. If there is no current, no voltage drop in the silicon. Voltage 0.7 will not be there. How much volt you will have then? How much volt you will have then? Not 0.7. You will have
0.
0.3 because the voltage remains same in parallel. But in 0.3, silicon do not conduct. In 0.3, silicon will not conduct because that is not enough. For silicon, 0.3 is not enough. So no current will flow. No current. Understood? No current will flow. The current will flow here. Only through the germanium. Okay? Only through the germanium. So the whole current, that means this whole current will go through the germanium. So now let's do the math again. How 10 volt minus I1 into 0.33, that means R1 minus 0.3, not 0.7, remember 0.3 equal to 0. From there, you will have I1 equal to 10 divided by 3.33. 10 divided by 0.33. It is 30.3. 30.3 milliampere. That is your current. Now it is your current. Now what about the ID1? What about the ID2? That is your I1. Remember, your ID1 equal to the whole 30.3 milliampere. What about the ID2? Will be 0 milliampere. Do you know why? Do you know why? Because your whole current, the 30.3 milliampere is this one, this current. And the whole current will go through the germanium diode. No silicon will have any current. That's why silicon voltage will be 0. Current will be 0. What about the voltage? If you measure the voltage, you will only get the voltage of the silicon. No, not silicon. You will only get the voltage of the germanium. Remember, if so, one important and shortcut method. If germanium and silicon, they are parallel, germanium will be activated, silicon will be deactivated. And what voltage you will have? You will have 0.3, not 0.7, because the silicon is not activated. If silicon is not activated, you will not have 0.7. Okay? Again, if silicon and germanium are parallel, germanium will be activated, silicon is deactivated. Germanium will give 0.3, silicon will not give any voltage, so the voltage will be 0.3 in parallel. Yeah. You understand something?
Okay, sir. So we can say, and if silicon and gallium arsenide is in parallel.
Okay. Then
So silicon is activated and
gallium arsenide
gallium arsenide
is not, right? And what will be the VO? That means what will be the voltage across them?
0.7 silicon.
Exactly. What is your role?
47.
47. Okay. Okay, you are exactly correct. Okay. So we will do
Okay.
more math in the next class. Understood? We'll more math about this in the next class. Okay.
Okay, sir.
Okay. We can finish it here today. And who is the CR?
Yes, sir. Muhammad Ali.
Muhammad Ali, I want you to do one thing every day. You need to call me before 10 minutes of class, okay?
I can hear you, sir.
I'm telling you, so you have one job. That is, you have to call me before every class.
Yes, yeah.
Can you do
Yes.
that?
Yes, sir, I do.
Yeah. Because I do not, I cannot memorize two different, two different departments of routine. I forget sometime when is your class, I forget.
Okay.
So you can remind me, sir, we have a class now, let's come to the class. Okay, do not call me at the moment of the class. Call me before 10 minutes so that I can turn on my computer, I can go to the Zoom, I can give you the link. Okay?
Okay, sir. Last time you said you will give us an application.
What application? Oh, the software, right?
Yes, sir.
Okay, I'm uploading now. Okay.
Okay, sir. Thank you.
Or I'm giving you a link, okay? I'm giving you a link. From that link, you can download that.
Okay, sir.
Okay. Thank you.
You're welcome.
Okay.